Hello folks, welcome back again to another video where we were practicing top interview 150 from Leetcode. So yesterday I did a problem by my own. I forgot to record it. So let's just do it again. It was the implement try prefix tree question. So let's just do it again. I will reset the code. Alright. So what it says is that a trie, pronounced as trie or prefix tree, is a tree data structure used to efficiently store and retrieve keys in a dataset of strings. There are various applications of this data structure such as autocomplete and spell checker. Alright, okay, let's open Draw. Okay, so what it says is that now let's see what is the data structure of trie. Okay, now we will have an array and we will have an array of something called as node. All right, that's it, and each indices will represent a character. A oh sorry, it will be A, let's just zoom it, then B, and etc. So therefore the size of this array will be 26 because there are 26 characters. Now we will create a data structure, something called as node. All right, this node will contain first of all the address of this array. Let's say we call it letters, and it will be an array of characters, okay, whose length will be 26. And also we will have a flag, let's say is n, because we have to see that whether this character is an end or not. We will come to this later, but yeah. So let's just resize this. Okay, so we will have 1 2 3 and let's say A, B, C, etc. And this array will be oops, I made a blunder. It will not be array of character, it will be array of node itself. All right, so this node will contain this. So what we will do is set, let's take an example. Let's say the word is ant. All right, so we will take the first character of this word A, and we will initialize a node in this index. All right, so a node will be there. What this node will point is another array here, another array that will initialize that. Okay, just a minute. That will implies that okay, this node is not empty and therefore it contains a letter A. Now we came to the letter N. Now in this array, let's say we have this index of N. All right, now in this index, we will again have a node. We'll initialize a node, and this node will point to another node, another node which will represent t. All right, so that means, let's say we come here, we come to this index, and this represent the letter t. So when we come to this index, we will mark that is and is true. All right, uh, is and equals to true, because this is the end of the word. Okay, let's just remove this. A will point to n, and n will point to t. Okay, so is and is true. Now let's say there is another word. Okay, let's say anti gravity. Let's not take this a long word. Let's say next we got another word which says anti. Okay, we will have the root array. Okay, we see that, okay, a is already filled, that means the letter already contains. We go to this array, we see that ant is already filled. We come to this, we see that t is already filled. Now we have to like add another array of I. All right, so that means um, it will have a array with the I with the I index, and it will point to here. So can you now see why is and is important? Because we can have multiple words, and these are called prefix. We let's say there is a word ant, we have been given ant, and later it was asked that see whether ant is present or not. So we come to a and t and see that, okay, this t is here, the t is marked as ant, so that means a word is there. Now let's say ant is not given, only the ant is given, then a n t I, and later it was asked that uh, let's check whether ant is present or not. So in that case, a n t is and will be false, so therefore that means ant was not given. So this is the basics data structure, how we will proceed and how this trie looks like. This is used in many practical applications such as autocomplete or spell check. It was given yeah, autocomplete and spell check. So yeah, so let's just start the coding. So we will have a class of node. It will have array of node letters. It will also have a boolean is and let's create a constructor. It will be an empty constructor. Now we will have many classes. First one will be to add. All right, for the for adding we will take char and node, and for this we will just put letters, character, just a minute, I think it will be, yeah, I think it will be letters. These dot letters will be new node 26. All right, so whenever we add a character, we will take character minus a, because we have to add this node in that specific index, so we will put add. Okay, next one will be to, let's say, get character. To get the node, we will just return letters ch minus a. Okay, now it will be like this. Then we will have methods such as boolean to check is and. Then we will say character ch, return letters ch minus a. We will check whether this is oh sorry, is and will be just a minute. Is and will be sorry, it is and doesn't, it will not take any character. We just have to return the whether this is the and or not. And one more thing is to set and, because this is a private variable, so we have to create a setter, set and is and will be true. We will also have to add one more function that says we have to check whether the letter is or the character is taken or not. So we have to just return letters ch minus a not equals to null. So that means if this index is not empty, that means the letter a is been utilized. So we are just returning that. Cool. Now let's implement it. Public try. We will have a private node root. We will have, whenever this is initialized, we will have root equals to new node. All right. Cool. Insert. So for the insert, we have to, let's say the word is apple. Okay, for this word, let me just think how we will insert it. Yep, we have to take the root address, then we have to iterate over each index. I less than word dot length I plus plus. We have to extract the character word dot caret I. Then if we have to see if temp dot temp, let's name it current, because we have to iterate over the arrays or nodes. Therefore let's take the current dot contains. We have to see whether it contains or not. If it doesn't contain, then only we'll proceed, because if it contains, let's, as I say, if we add a and t and again we add nt, then since a is already contained, so we don't have to do anything. Okay, we just have to like pass the value of this index. So we will do that, but let's say if it doesn't contains, then we will say current dot add then character. We'll use this function character, and we will say that new node, add a new node. So therefore in the first case a was empty, we just initialized another node and added this address to this index. We just have to say current equals to current dot get ch. So therefore now current was here, current was pointing to this node. Now we say get a, that means it will, now the current will be in this node. All right, now we don't have to return anything. We get ch and we just have to mark current dot set end. We have to mark this as true, right? Because and t, it is a word, t is the end, so at the end we have to mark is and is true. We will use this setter function isn't. Okay, now for searching we will again, like the steps is more same. It will be root int I equal to 0, I less than word dot length. Oh, it's a string, so therefore it will be this method I plus plus character ch equals to word dot current I. Then again if current dot contains ch, if it doesn't contains, then if doesn't contain, then we will directly return false. Because see, let's say there is another word, okay, a and d. Now we comes here, a is present, we comes here, and is present, we comes here, the d index is empty, right? So since it is empty, it will return false, and if it returns false, this will become true, therefore it will return false. We just have to check that whether this word is present or not. Okay, and after that current will be, if it comes out of here, that means the letter is present, so therefore we just have to get this character. And if we come out of this, we just have to return current dot is end. See, let's say we were given first the word end time. Okay, leave end and end. We were given the word anti, so anti. Now we were given that, okay, search for the word ant. Okay, ant, we come here, the word, the letters are present, but this is and will be for this I. We haven't like added the word and, so therefore this is and will be false here. So we were asked that whether this word is present or not. So therefore we will check, we'll come here and we will return is end, because we have to like return, we have to just check whether this whole word is present or not. If it is true, then okay, the word is present. If it is false, then okay, the word is not present. Now comes this second method. It says starts with, that means we have to just like check the prefix. So in this case the word is anti, we were first given the word anti, and now it has, now we have to check ant prefix. So the prefix is there, okay, ant. So therefore in this case it will be returned true, because here we are not checking the whole word. Alright, we are just checking whether the prefix is present or not. So therefore the implementation will be same. it will be same. If it doesn't contains, if it doesn't contains, then okay, return false. But if it contains, then we will not check whether it's end or not, we just have to return true, because okay, the letter is there, it doesn't matter it is the end or not, we just have to return true. All right, now let's check it, let's run it. Okay, there is some word. Okay, this is the prefix, we just copy it. Okay, okay, it's running, let's submit it. Cool, it's been accepted. So this is the try method. It's very important for interviews. It may be asked, the once you get the hang of it, like how the data structure works, it's very easy to implement and easy to remember also, and it has many practical application also. Keep practicing, and I will see you in the next video.